This is Josh. He's a mathematician and a musician, and he wants to know how math and music are related.
I really wish I knew a way math and music were related.
You're in luck, young one, for I am the one.
Nani? Who are you?
For I am the guru of math and music.
So you can help me with my problem.
Yes, my holy prophets, Brandon, Noah, and Fikra will explain to you how math and music is related.
Yes, sir, mighty guru. To start things off, Brandon will be talking about wavelengths, frequencies, and hertz in music.
When music is played using an instrument, the vibrations created either rubbing, plucking, or blowing releases sound waves. The frequencies to which they release is one similar to a sinusoidal graph. Frequency is the number of occurrences of a repeating event per unit of time. Each different note played releases waves at different frequencies, causing the pitch to sound either lower or higher. A higher note releases at a higher frequency than a lower note. For example, the high E note has a much higher frequency than a low A note. Specific distances between these frequencies are represented as scales in the musical world. The different frequencies are identified using hertz. The same E note has 1318.51 hertz, and the same A note has 440 hertz. The specific arrangement of notes from lowest to highest is called a scale. The order of the notes in a scale starts at the note with the lowest amount of hertz and ends with the highest. For example, the C scale starts with C, 261.63 hertz, and ends with a higher C, at 523.25 hertz. As you see, the musician played 3 notes simultaneously. We call this a chord. The reason it sounded like this is because the 3 notes he played didn't have cooperating wavelengths. He played a C, C sharp, and D. These notes are half steps apart, meaning their frequencies are very similar. Hearing these notes played together can show the opposing wavelengths interfering with each other. This is called dissonance, and when it sounds more pleasing, it's called consonance. Understanding the different wavelengths and frequencies can influence whether or not the sound is pleasing to the human ear.
Is everybody still awake? Yeah, that was Brandon talking about frequencies and wavelengths. Now it's time to count. Let's go down to Fikrob with the time signatures of music.
Counting has never been harder. The time signature of a piece determines how many beats in a measure and what notes get one beat. In a standard time signature, there are 4 beats in a measure, and a quarter note gets 1 beat. These time signatures are represented by fractions such as 4/4, 3/4, 6/8, and 47/16. The numerator determines how many beats in a measure, and the denominator determines what note value gets 1 beat. Sometimes a time signature can determine if a piece is jazz or if it's fun to play. There are many different notes with different note values. A whole note has 4 beats, a half note has half the value, a quarter note has half the value, an eighth note has half the value, a 16th note has half the value. There is this thing called a dot that makes everything harder. A dot adds half the value of the note it's next to. For example, a half note has 2 beats and a dotted half note has 3 beats. A quarter note has 1 beat and a dotted quarter note has 1.5 beats, and so on and so on. Time signatures also influence a musician's approach to a piece. There are many different styles of music with different time signatures. A typical waltz has a time signature of 3/4, marches are usually 2/4, and jazz, it's all over the place. Right now, the musician is doing what the music community calls subdividing. This is a fancy way of saying complicating fractions. To make a song easier, you could change the time signature from 3/4 to 6/8. This aids the musician in calculating the rhythm of a piece with notes of smaller values. For example, if a measure is counted with eighth notes in a 4/4 time signature, the musician could count them like they are quarter notes in an 8/8 time signature instead. This form of counting beats keeps the band or orchestra in time playing the same notes in the same rhythm.
And I'm back. Whew. Some hardcore mathematics right there in music. Now Josh is going to show us what the guru taught him on his own, and he's going to play a little song for us. Hit it, Josh.
I've taught you all that I can, young one. Now it is up to you to teach others and to stop forest fires.